All right, so the other day we were talking about similar triangles have the same angles, okay? That is a key factor. If they are similar, their angles are all equivalent, okay? They're just larger or smaller. They're of a different size, okay? One of the things you need to be careful is make sure you don't make an assumption. You can't look at it and make the assumption that they're going to be similar. You're going to have to make sure of that. So, tell whether the triangles are similar. Look at A. Are the triangles in A similar? Are they similar, Cadence?
No,
How do you know?
because they both have a 75-degree and 50-degree angle, and if you were to turn the smaller one, like turn them to be the same.
Okay. Also, what do we know about the degrees of the triangle? How many degrees are in the interior angles of a triangle?
180.
180. So if both of these have the same, then we know that third one is going to have to be the same, because if you subtract 75 and 50 from 180, you're going to get the same answer every time. So yes, these two are similar. What about B? Are the two triangles similar in B? And you have to be able to defend it. Natalie?
No.
Okay, why do you think they are not? Tell me how you know it. Okay, because you didn't do anything, you're just looking at them, and so you're making an assumption, right? Don't make assumptions. Make sure that you know. Okay? Ridley.
No, because that one has 54 and 63, and the other one has 63 and 63.
Well, why couldn't that be 63? I mean, nothing's saying, unless you've done something, you can't tell me whether it is or not.
Yeah.
Are they similar, Lindsay?
Yeah, because 180 subtract 63, subtract 63. I added 63 and 63 and subtracted it.
Okay, 63 and 63 added together equals what?
126.
126?
And add that.
And that equals 54? So then that tells you that that angle right there is 54 degrees, right? That's what I hear you telling me. So yes, they are similar? Okay? Don't make the assumption though. Tell me about C. Are they similar? What do you think, Miss Olivia?
No, because if you subtract them from 180, it gets different.
Okay. So this one here, I've got 180 minus 132. Am I right?
Yeah.
And what do you get when you do the subtraction there? 52 degrees. So that would say this one's 52. And over here I've got 180 minus what? 128. And when I do the math, I get what?
No,
I better not get 52. What's 180 minus 128?
56. 52. Oh, 52.
Well, then this one's wrong.
Yeah, I was saying, because 180 minus 128.
Yeah,
No, we can do it. 48. That one's 48.
Pick the two.
This one is 48.
Yes.
See, I'm just listening to, I'm taking the values that you guys are giving me.
Yeah, because it only equals 170, so it has to be.
So then this one's 48 degrees, and this one over here is 52 degrees.
Yeah.
So they are not similar. Okay? Understand why I say don't make that assumption. Don't assume that they're going to be similar. Do the math. Do the calculation. Joey.
Would this work for all of them? Like, because I used it on the orange one and this one. You just 90 plus 38 plus 42, and if it doesn't equal 180, it's not similar. Because it's getting numbers from both triangles. And if they were similar, it would be 180.
You're saying you took the 90 plus 42
Then plus 38. on the
plus
other
this 38.
triangle. Yeah.
But if you add, A together.
But what he's saying is 90 plus 42 plus 38 doesn't equal 180. So this one could not be a 38
Because
degree.
it's like plugging a 38 into
So-
vertexes.
I don't know if it would work all the time. It might, but I can't tell you without doing a few more.
I don't like. I think it. Are they only the triangles on this? So is it? Only,
That's all we're talking about is similar triangles.
like I think if there's two unknown numbers, it would work. But I don't know.
Okay? Okay, now we're going to use proportionality. We're going to talk about how we can use that to find an unknown measurement. That's where we're at here, where we're at. Use the fact that the two rays from the sun are parallel to explain why triangle ABC and triangle DEF are similar. Why would they be similar? What do you think, Mr. Ty?
They're similar because all they did was, times them both by 12 and they got the bigger one.
You're timesing them both by 12.
Or you times the little one by 12.
Okay,
It's
36
12 times
is-
bigger. The flagpole.
it's 12 times larger, okay? If these two lines are parallel, then we have a 90 degree, could we call this would be like having the transversal, right? And so if they're parallel, they would be setting in the same spot as far as the angles go. So, okay, I agree with the 3 feet and the 12 times larger, okay? Can I use the similar triangles now, though, to find the height of the flagpole?
Mhm.
Can I use the fact that they're similar triangles to find the height of the... I'm trying to get it where I can see that. The height of the flagpole. And how would I calculate it?
12 times. Yeah, that's 5 times 12. 60. And 3 times.
You're saying if I take the 3 and 36, wait a minute, that's not the one. But that's gonna be equal to 36 and x, right?
Mhm.
Okay, and you're saying because this was multiplied by 12 to get 36, if I multiply 5 by 12, I get 60, or the height of the flagpole, okay? That is definitely one way to do that. What if your number sense didn't allow you to see that? You just didn't automatically see it. Do we have a proportion though? Can we compare the two proportions? Oh. Can we compare the proportions and solve the proportion to find that value? And if I do, how do I do it? Because you need to be able to know how to do it both ways. Lindsay,
You cross multiply 36 and 5.
I'd cross multiply and I'd have 3x equals, what's the 36 times 5? What was it?
180.
180? And then divide by 3. 60. And you get 60. Okay? So I want you to know how to set up the proportion so that if you just don't automatically see how they're proportional, to where you, number sense told you you could multiply by 12. But it's not always that easy, is it? Okay? And that's the part, you have got to know how to use the proportion. Okay? And so ultimately, your final answer on that would have to be 60 feet, right? We're dealing with a story problem. Okay? Okay? Here's another example. And this one I know you will see again. Similar. Something similar to this again. Okay? So I'm telling you, you got to understand it. All right. Angles. Let's see. You plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river and make a drawing as shown. Explain why triangle ABC and DEC are similar. And then it wants to know what is the distance across the river. Why are they similar? And what is the distance across? I think it pretty much gives us the why they're similar, doesn't it? Angle B and angle E are right angles. Okay? We've got parallel lines, don't we? And they're being cut by that transversal. Angle B and angle E are right angles, so they are congruent. Angle ACB and DCE are vertical, so they have to be congruent. Here's my vertical. ACB and DCE, these two are vertical, so they have to be congruent. Okay? Because the two angles of ABC are congruent to the two angles of DEC, the third angles are also congruent. If you know that these two are the same and these two are the same, then you know they're going to be similar. Okay? Because we've got the same angles. Okay? Write a proportion, or I don't care how you do it, but tell me what is the length from, what was it asking us? The length? Across the river from right here. What is the length of the line segment CD? It tells, DE. It wants this length. DE. Solve for X. And you've got to be able to tell me how you did it. Take some time, look at it. Get it on your notes, because I'm telling you, and I can't tell you any clearer than I am, you're going to see this type of a problem again, more than once. Would you please go get them so you'll have them? Got it? Olivia's got it? How'd you get it? That won't work. 180 is a degree, not a length of the sides. That won't work. Is it in the classroom? What did you do with it? So let's open a binder and look and see if it's in there. It's 3.4. I don't know if I have another set. If I do, I'll give you one, but I don't know if I do. I threw a bunch of them away this morning that I didn't need any longer. I don't have another set. what we're gonna need to do is maybe we'll get you another set later, cause I've gotta move it. Go ahead with this. All right. Somebody tell me, how am I gonna set that ratio up? To be able to compare them? How am I gonna set it up? You guys have your whole picture. What am I gonna do, G? What do you think?
50 over 60 is 40.
50 over 60. He says 50 over 60 equals 40 over X. Is he correct? Is he correct?
Yeah.
Okay, and then we gotta make sure we're comparing side to side. If I laid that up, okay, that would probably work. Could it have been set up 60 over 50? Could we have done it this way? Is that gonna change it in any way? No, it won't, okay? So if we cross product, 50x equals how much? 60 times 40 is
2,400.
2,400? And then to solve for x, we would have to divide by 50. If you don't have the notes, you probably ought to have out a piece of paper and take the notes on paper. Okay? So if we divide both sides by 50, x equals what?
48.
What does x equal? 48. Okay, a while ago I had some say, no, they didn't think that was gonna give us what we needed. Madison?
Well, I got the same answer, but since 50 and 60 are on the same triangle, like, okay, so I had 40 over 50 equals x over 60.
Okay, so you put and that's fine. How you set that ratio is fine as long as you're making sure you compare to the same stuff, okay? A ratio is one of those that you can do the part to the whole in several different ways, all right? The
How
part
would
to the
that
part.
work? How would that work? I don't
Okay, here's what she did. Say it again. You did the 40 over 50, Madison?
I did 40 over 50 equals x over 60.
Okay, she's taking these two, taking the smaller triangle here, taking the 40 and the 50, and as long as she takes the x and the 60 next, she would be fine. If she reversed these two, it would not work. Because she's taking the leg of one triangle over the leg of the other, and then the leg of the first triangle over the leg of the second triangle. It's still gonna work for you. Okay? Whichever way works is easier for you to see it. It's fine. I do the way you guys did it originally. Because for me, that's just easier. But this is acceptable. The biggest thing though is to make sure that what you're comparing is the same. So this would be triangle A, and this is triangle B, and this is triangle A, and this is triangle B. Making sure you keep those the same, okay? Any questions on that? Are you good with it? Okay. Here, I changed the assignment. It's not the same assignment as what's written on your notes, so you need to change the assignment on your notes. Okay? And I did that because I know 13 and 15 specifically are a couple of similar story problems like what you're going to be seeing on Tuesday. And if I'm telling you you're going to see it on Tuesday, it's going to be on your what?
Test.
Test. Okay?